Now, using a knife switch, we will look at the basic parts of a switch. Now, I have modified this switch to make it the simplest switch possible for this lesson. Now, the first part of the switch we are looking at is the white base or housing of this switch. It is made from a material that is a good insulator. In this case, it appears to be a glazed ceramic. The housing or base provides an insulated mounting for all the switch components, which you can see are mounted. And they have recesses for mounting the components in. And on the bottom side, there are screws that fasten the parts firmly in. And I'll flip it over so you can see the screws. So you can see there's two screws here holding the parts of the switch to the base of the switch. Now, the base or housing of a switch also provides a means for mounting the switch onto a board or plate or even in a box. This switch has two holes so that we can conveniently use these two holes to attach it to something else with screws. And you can see there's a hole here and a hole here. So if we wanted to mount this switch onto this board, we would just use a wood screw here and a wood screw there, and it would be firmly fastened. Another part of any switch is what we call the contacts. Now, the contacts of this switch are composed of the knife and the jaws. So this is the knife and this is the jaws, and both of those are considered a contact. And if I move the knife into position, it contacts the jaws. So that's why we say they're both a contact. So now my contacts are in contact with each other. The knife is in the jaws. And I will also show you from a side view of how the contacts connect. Okay, here we're viewing our knife switch from the side view to give a very clear picture of the action of a knife switch. So the second part to describe of a knife switch is the contacts. Now this part is the knife, and it's considered one of the contacts. And then this part over here is the jaws of the switch, and that's our second contact. And the switch closes by moving the knife, which is one of the contacts, into the jaws, which is the second contact. And once they contact each other, the switch is closed, and there the knife switch is fully closed. And an electrical connection is made between the switch terminals. Now notice also that the knife has a riveted hinge, and it's also in a set of jaws, but this end is always in the jaws, and it rotates 180 degrees because of the hinge. And it also keeps it aligned, so it lines up with the jaws that act as the contact for the switch. So the third part that we can see for this switch is the insulated handle. It is only by this insulated handle that a person can move the knife without being in electrical contact with energized conductors. Now I'm giving a demonstration of how a knife switch operates. I have connected my multimeter leads to the two screw terminals of the knife switch. As you can see here, the black is on this terminal, the red is on this terminal. And now I am turning my meter on to ohm meter mode so we can measure the resistance of the switch. So now my meter is on and it's in resistance mode. The ohm meter is showing open lead, which is greater than 100 million ohms. The switch is in the open position, so no current can flow. Current is not able to flow through the air or through the insulator base. The switch is called off in the open position. Now I'm going to close the switch so the knife and jaws make full contact. So see, now I'm moving the knife, and now the knife and the jaws are making full contact. Now the resistance is 0 ohms. My switch is acting like a really good conductor, and current is flowing from my multimeter through the switch and back to the multimeter and giving us the 0 resistance reading. The switch has closed the circuit so the ohm meter can read 0 ohms. The switch is called on in the closed position. Now we're going to learn about some special switch terminology, and we're going to do it by looking at our knife switch. So the first part with a special name is the knife, which is called a pole. So the moving part of our switch and of most switches is referred to as a pole. So it's the pole that moves in the switch. And the second special terminology is the throw. And the stationary contact of our switch is referred to as a throw. And my modified switch is referred to as a single pole, single throw switch, which is shortened to its initials SPST for easy use. So this switch's operational capability is defined as an SPST switch. SPST switches are the simplest but also widely used in all our electrical and electronic devices. All of the light switches we saw earlier in the lesson 4A are SPST switches. Let's look at another more complicated knife switch. Poles. In this switch, we have two separate poles separated by the insulated handle. As you can see, here's one pole and here's a second pole. But they're electrically isolated from each other by this insulated handle. And then for each pole, I have two throws. So here's one throw and a second throw for this pole. And then here's one throw and a second throw for this pole. And I can throw this switch in two positions. So right now it's in the first position, and then I can throw it into the second position. So we have two positions, or two throws as we would say. This switch is referred to as a double pole, double throw switch. It's called a DPDT switch by industry to define its operational capability in a simple way. Let's look at the momentary contact microswitch now. It has three terminals with some small letters above them. The left terminal has the initial C above it. This initial stands for the common terminal, which is the pole contact of the switch. In the middle, we have the normally open contact with the initials NO above it. And the right terminal has the initials NC, and this stands for normally closed. And both of these contacts are called the throw contacts of the switch. Because this switch has one pull and two throws, it's called a single pull double throw switch. And for short, it's called SPDT. And if we want to give a total name to this switch, we would call it an SPDT momentary contact micro switch. Remember, SPDT means single pull double throw. Now we will look at how the micro switch works with the ohm meter. I have got the negative lead of my multimeter connected to the micro switch common with this black alligator clip here. And I've got the positive lead of the meter connected to the normally open terminal with this yellow alligator clip here. And the meter shows open lead when the lever is not pressed, telling us that the common and normally open contacts are open. Now, when the lever is pressed, I'm just going to press the lever here, we see close to 0 ohms. Oh, there we go, there's 0 ohms. And this tells us that the common and normally open contacts are now closed. And when I release the lever, the contacts return to the normally open state as we see open lead on the meter once again. Now I will connect the positive lead of the meter to the normally closed contact labeled NC. It shows 0 ohms when the lever is not pressed. It shows us the common and normally closed contacts are closed. And when I press on the lever, it goes open lead, telling us the common and normally closed contacts are now open. When I release the lever, the contacts close once again, and our resistance goes back to 0. Well, we have learned a bit about how switches work and their terminology. Please watch the next lesson on fuses. We will plan to build our first circuit once we have learned about fuses and light emitting diodes.